And in the last class we have studied regarding the forward biasing of the semiconductor diode. So before that we have studied what do you mean by biasing is. So biasing is nothing but if you apply external voltage to the semiconductor diode, then it is called as biasing. External apply voltage, if you apply the external voltage, then the condition is called the biasing. Then forward biasing means P type is connected to positive and N type is connected to negative terminal of the battery. Such condition is called the forward bias. Here today we will see what do you mean by a reverse bias condition as well as the characteristic of semiconductor diode. So in the reverse bias condition, if you take semiconductor diode, if you take the semiconductor diode, P and N type together join to form a semiconductor diode. Here in the P, and this is what N is. Here I can say holes are the majority charge carriers, and in the N type electrons are the majority charge carriers. And here some electrons are there, those are minority charge carriers. Here it becomes negative plate, negative ionic plate, and here it is positive ionic plate. And field, or you can say potential barrier, is from positive to negative. This is regarding the PN junction. Then in the reverse bias condition, this is what the situation is. So how can you say this is what the negative plate of the battery and this is positive terminal of the battery? How can you say it now? How can you define the reverse biasing of the semiconductor diode? Here you can see the P-type semiconductor is connected to negative terminal of the battery and N-type is connected to positive terminal of the battery. If P-type semiconductor of the diode is connected to negative terminal of the battery and N-type of the semiconductor is connected to positive terminal of the battery, this condition is for the reverse bias condition. This is what the reverse bias condition. So let us write its statement first. Its statement: P type is connected to negative terminal of battery and N type is connected to positive terminal of the battery. This connection gives the reverse biasing of the PN junction. This gives the reverse biasing of the PN junction. Now, see here the applied voltage is from positive to negative. Here I am mentioning V. Now you can see the resultant voltage or resultant the field, resultant the potential. You can say both are in the same direction. You can say the resultant potential is sum of V and VB. Hence, the potential barrier, net potential barrier, you can say it is the algebraic summation of applied voltage and barrier potential. So, if the barrier potential earlier this much, if the barrier potential earlier is this much, and this is what the applied potential is, then the resultant barrier potential becomes V plus VB. So first we will talk about the resultant barrier potential. Resultant barrier potential increases. Initially it is VB. Now you can see its height is bit smaller compared to the resultant. Hence you can say the resultant barrier potential increases to V plus VB. So that is what the first point is. Why it is increasing? Because the applied potential and barrier potential are in same direction. Because of this reason, applied potential and barrier potential are in the same direction. Because of this reason, the resultant barrier potential increases. So first point is talking about the resultant potential. So net barrier potential increases to V plus VB, applied voltage plus the earlier barrier potential. If the barrier potential increases means energy barrier is also increasing. Energy barrier means energy required to cross the junction. Energy required to majority pole carriers. Here the minority carriers are positive poles. Majority charge carriers to cross the junction needs more energy here because potential barrier is increased. So here you can write energy barrier across the junction is increases. So here you can say energy barrier is also increases. Energy barrier means energy required to cross the majority charge carriers across the junction, which is more here. Then secondly, here you can say applied voltage and barrier potential is in the same direction. Because of this reason, or you can say here negative plate is there and positive plate connecting P type and N type respectively. Negative plates start attracting the holes. So holes are coming towards this region and electrons are coming towards this boundary. Hence, what is the depletion region is there earlier, that becomes wider and wider. Because of what? Because of negative plate is connected to P type, holes are start attracting towards the negative plate, and positive plate is connected to N. Electrons are starting attracting towards the positive plate. Hence, the depletion region go on increasing, or you can say width of depletion region go on increasing. So second point, in the reverse bias condition, width of depletion region increases. So if the width of depletion region increases means resistance of this diode increases. Depletion region go on increasing means it is very difficult to cross the majority charge carriers across the band. You can say because of this reason resistance of diode increases. The resistance of diode increases. If the resistance of the diode increases means current is not flowing because of the majority charge carriers. But you can see here some amount of minority charge carriers are there. Very little amount of minority charge carriers are there. Those crosses the junction, and because of the minority charge carriers, current is flowing. Here, whatever the current flows, very little amount of current is flowing in terms of microampere. That little amount of current because of the minority charge carriers. So here you can write another point. Current flows because of minority charges, minority charge carriers, and this current is in order of microampere because the number of minority charge carriers are very limited. Hence, whatever the current output you will get, that is in terms of microampere. So these are some points you have to remember while discussing the reverse bias condition. Those are, first point, how the connection is. P is connected to negative and N is connected to positive. If it is happening so, next point is the potential barrier is increases. If the potential barrier is increasing means energy barrier also increases. So these are the 3 points. If the potential barrier is increasing means resistance is also increasing and depletion region width is also increasing. And here whatever the current is flowing only because of minority charge carriers, and that current is amount of only in terms of microampere. So just take out the screenshot and make the notes. So hope you have taken out and try to note down, try to make the notes by using these all the key points. So okay, now we will see how the current and voltage varies in the reverse bias condition. We said that when potential difference applied to the diode, the minority charge carriers start crossing the depletion region, or you can say barrier, hence they induces some current as the voltage applies. So here 0 volt, there is no current. As the voltage go on increasing from 1 to 20, the current is set up. And this current, whatever the current is set up, this is because of the minority charge carriers, and this current is called as reverse saturation current. This is called as reverse saturation current. I will mark point here and I will name it as reverse saturation current. Reverse saturation current. Once this reverse saturation current is set, it remains constant up to certain voltage. As the voltage go on increasing, here external voltage go on increasing, but the reverse saturation current remains same up to certain voltage. Why it is so? Because the number of minority charge carriers are limited. Suppose, let us assume that minority charge carriers, you can say electrons or holes, are 10. Suppose we are assuming minority charge carrier, number of minority charge carriers are 10. When potential difference is applied, you can say 1 volt of potential difference is applied, one minority charge carrier flows across the junction. Because of that one minority charge carrier, little amount of current is developed. As the voltage go on increasing, let us say when it becomes 10 volt, 5 number of minority charge carriers crosses the boundary and causes the current. Means 5 number means somewhere up to here current is built. Once it becomes 20 volt, all the 10 major minority charge carrier crosses the boundary and leads in current formation, leads in current flow. So once all the 10 minority charge carrier crosses the boundary, the current set is up to this much. Whenever you increase the voltage, those 10 number of minority charge carriers only has to cross the boundary and come here, once again pump back. Only 10 minority charge carriers are only there. So because of that, 5 microampere of current is developed. So it remains constant up to certain voltage. As the voltage go on increasing, this current, saturation current remains constant. This is called the reverse saturation current because this is because of minority charge carrier. Up to certain voltage means when the voltage increases more than this voltage, current suddenly increases. So with the minute increment of the voltage, sudden increase in the current takes place. Why it is because so? We will study in the next class or forthcoming lectures. So whenever at what voltage current suddenly increases, that voltage is called as the breakdown voltage. So at the breakdown voltage, current in the reverse bias condition suddenly increases. And here also you can define the dynamic resistance Rd as delta V by delta I, and static resistance Rs is equals to V divided by I. Same as in case of the forward bias condition, only the notation or small r we have used. So this is regarding the relation between V and I for the forward bias, reverse bias condition. So remember, as soon as voltage increases, current is also developed in the diode, and that current reaches certain value called as the reverse saturation current. Once the reverse saturation current is met, that current remains constant up to the certain voltage. That is what the breakdown voltage is. Further small increment in the voltage, very large increment in the current takes place. So this is what the nature of graph between V and I. Just take out the screenshot and make the notes. So hope you have taken, and now we will see how the characteristics of the forward bias and reverse bias condition. So we will discuss the characteristics of forward bias and reverse bias condition. Means it is nothing but voltage and current relation for forward bias and reverse bias together. We have already drawn this. For forward bias we are drawing in the first quadrant, and for the reverse bias both current and voltage are negative because in the reverse direction, and it is the reverse saturation current. So we have to draw in third quadrant. Now as you know, for the forward bias, here I write forward bias, and here I write the reverse bias. So whatever the graph I am drawing for the current and voltage curve, this is here, this is called the reverse bias, and whatever drawing in this quadrant, that is called the forward bias. In the forward bias, as you know, once voltage go on increasing, first initially up to the barrier voltage there is no current. Once the applied voltage reaches the breakdown voltage, or you can say the cut-in voltage, after that the current goes on increasing. For once the voltage reaches to 0.2, there is no current. 0.4, there is no current. 0.6, little bit current induces in the diode, because whatever the energetic electrons are there, after absorbing the energy, they just cross the boundary, very little bit current is induced. Once the potential reaches the cut-in voltage, suddenly current increases. Furthermore, voltage as increases. So this is what the curve is, and this is the cut-in voltage. So this is what the cut-in voltage. And here whatever the current we have got is in micro ampere. And cut-in voltage for germanium it is nearly 0.2 volts, and for silicon it is 0.7 volt. Nearly it is 0.2 and 0.7 volt. Means when you are using germanium crystal of P and N type semiconductors, or you can say diode, germanium crystal diode, if the applied voltage reaches 0.2, then suddenly increment in the current takes place. Whereas if you are using silicon, it needs 0.7 to increase the output current. And similarly for the reverse bias condition, as the voltage is applied, when the voltage is 0, there is no current. As the voltage go on increasing, because of the minority charge carriers, current goes on increasing and reaches certain value. That certain value is called, and right here with the black ink. So here whatever the current reaches because of the minority charge carriers, that current is called the reverse saturation current. So reverse saturation current. This reverse saturation current is mainly because of the minority charge carriers, and this current remains constant up to certain voltage. So this current remains constant up to certain voltage. Once applied voltage reaches the breakdown voltage, current suddenly increases, and the applied voltage where current suddenly increases is called the breakdown voltage. So this is regarding the characteristics of forward bias and reverse bias. While dealing with the characteristic of forward bias and reverse bias conditions, you have to remember the cut-in voltage in case of the forward bias, and in the reverse bias, what do you mean by the reverse saturation current and what do you mean by the breakdown voltage? You have to do. So just take out the graph and do some notes. Hope you have taken down. And okay, so today we have discussed regarding forward bias condition and reverse bias condition. Forward bias condition, you have to remember P is connected to what positive terminal and N is connected to negative terminal, whereas the reverse bias condition, P is connected to negative terminal and N is connected to positive terminal, and respective graphs we have drawn and combinedly I have shown here. So this is called the characteristics of forward bias and reverse bias condition. So I am stopping here. I'll stop here and I'll continue in the next class. In the next class, we will study what do you mean by rectifiers, what do you mean by full wave rectifier, half wave rectifier. We will study in the next class. So I'll stop here and thank you.